Hi guys, this is Mr. Urrego. Welcome to our Algebra 1 EOC review. Today we're going to work on a test that is called Beat the Test. This is a practice exam for the Algebra 1 EOC end of course exam. This test is given by the official Florida EOC website. Okay, so this is the people that make the test, the official test when you're at the end of the Algebra 1 course. Okay, so it's great. So let's pay attention and let's work on this. All right, question number 1. They're saying which inequality is represented by the graph below. I have 4 inequalities, I have a graph. So this is an inequality, this is a shade. If you notice, I have a line. This is my line, right? It's dotted line right now. This is my line. And it's a dotted line. When it's a dotted line means your inequality symbol is going to be either less than or greater than. When it's a solid line, it's going to have an equal underneath. All right. All of them, they don't have the equal sign because this is a dotted line, right? Makes sense. Now, when I have the y less than, then my shade is going to be under my line. When I have greater, and let's say that all of them has y, let's say the first one, 2/3 of x minus 3, right? Let's pretend that I have one with greater. Let's do the last one, negative 2x plus 3. So when I have y isolated, y is less than the rest of the equation, then my graph, let's pretend that this is the line, the graph is going to be below the line. When I have y is greater, then let's pretend that this is the line, y is greater, then the shade is going to be above my line. All right, so right now I see a y greater. Y greater, it should be above the line, so that's not an answer. The other 3 are less than. Excellent. Now, how do we identify which one we're doing? Because remember, this is the equation of a line, right? mx plus b in slope into form. So where any number in front of the x is your slope, and the number after plus b, that's your y-intercept, right? But in this case, instead of having an equal, I have a less than, right? But the equation behaves the same way. So what I need to do is I need to find out what's my y-intercept, because remember, this is your x-axis and this is your y-axis. So how much is your your y-intercept? 1, 2, 3, 4, 5. So my y-intercept is 5. So I'm going to go to my equations. I'm going to see which ones has a 5. Look at this. I have a 5 here. I have a negative 5. I have negative 3. That's not the one. But now this is a positive 5. The only one that has a positive 5 is C. So my answer is C. Okay. Because this one has a negative 5, which should be a point right, my line should be going through that, and it's not the case. So that's not the answer. My answer is C. One more thing, let's double check. So my final answer is y is less than negative 3x plus 5. Now I know that this is my y-intercept. What about my slope? Okay, let's double check the slope at the same time. My slope, so if I'm going to graph this line, I will go straight to my y-intercept, and then my slope is negative 3. Make it a fraction, and remember that your slope is rise over run. In this case, because your rise is negative, I'm going to go down. So I'm going to go down 1, 2, 3. And then my run is 1, which is positive, which goes to the right. As you can see, those are the points. This is my slope from this equation, so my answer is C. Nice. We just review a lot of topics right there. Let's go to the next one. So number 2, the question is, which is the simplified form of this expression? They give me an expression. What I need to do? I need to solve it. Okay, so here we go. So I have 2x plus 3 times x minus 6 minus 2x squared plus 3x plus 30. So as you can notice, I have 2 parentheses here. So that's the first thing that I need to do. Okay, so I'm going to multiply these two. I have 2 terms times 2 terms, so I'm going to do FOIL. 2 times x is 2x squared. When you multiply and you add the exponents, 2x times negative 6, negative 12. Then I did already the 2 times the other 2. Now I take the 3. 3 times x is positive 3x. 3 times negative 6, positive times negative is negative. 3 times 6 is 18. And I just did the multiplication. Okay, let me rewrite everything else. Minus 2x squared plus 3x plus 30. And now I'm going to combine like terms. Okay, combine like terms. We start with the highest exponent, which is the x squared. I have 2x squared. Let's check for anything else. I have another 2x squared. There's nothing else. 2x squared minus 2x squared, 0. They cancel out. They're gone. Next, let's go with the x's. Negative 12 plus 3 plus 3. So negative 12 plus 3 is negative 9. Negative 9 plus 3 is negative 6. So it's negative 6x. I keep the same variable, same exponent. All right, the last thing is my constant, numbers without a variable. Negative 18 plus 30. Negative 18 plus 30, or 30 minus 18, which is 12. Now we check which one is the right answer. And the right answer is the last one, D. All right, combine like terms. Let's go to the next one. So let's work on number 3. Number 3 is a big problem. Look at this. A lot, a couple of charts, a lot of questions. So you got to read carefully and see what the questions is, and then concentrate on the question. So I have a Florida chart here, county population, a Texas chart, county population, kind of the same thing. First quartile, median, third quartile, largest, okay, smallest. Florida has 67 counties and Texas has 254 counties. Wow, okay. The mean population for the state of Florida by county is 291, with a standard deviation of 467,012.03. And the median is this. The mean population for the state of Texas is this, standard deviation and mean, and the median, right? So they give me the same information for both counties, for both states, I'm sorry. Some of the data for both states are shown, okay, so they give me this. Business moves its corporate location from Texas to Florida. So it's going from here to here. As a result, 8,000 people move from the largest county, from Texas to the smallest county in terms of population. Okay. Select all the population statistics that will affect this population change. Oh, interesting. So there's a lot of things going on. First of all, let's look at each table. They're saying the smallest, first quartile, medium, third quartile, largest. So I'm gonna make a graph a little bit. I'm gonna make a graph of what is called a box and whisker plot, and that will show us this data on a graph. And I'm going to do it for Florida, I'm going to do it for Texas. All right, so the first thing that we're going to do is that box and whisker plot. The second thing that we need to do is what's mean. All right, they're saying mean population for the state of Florida. Mean is the same as average. So mean population. So this is the average for every state. What about the standard deviation? What about the median? If you notice, the median is also here in the box. So median is your middle value. Median is your middle value. And I'm going to give you an example. I'm going to write an example. All right. So I need to understand what the mean is, the average. Standard deviation, I'm going to show you the formula in a minute. But the median is the middle value. Okay. I'm going to show you that on box and whisker plot that I'm going to do for each one of this thing. The second thing is we need to see what question they're asking me. All right, so before we proceed, they said that the business is going from the largest to the smallest. And it's going to be around 8,000 people, right? 8,000 people, 8193. So I'm going to be subtracting 8193 people from here, and I'm going to add it to the smallest one because that's what's happening. So in terms of statistics, look at this thing. 8,000 people compared to 4 million. Is it a big number or a small number? Or at least, if I subtract 8,000 people from 4 million, what's going to be more impact? subtracting from 4 million or adding it to 8,000 people. So I hope you're understanding that if I subtract 8,000 people from 4 million, this is a tiny number in terms of 4 million. But if I add it here in Florida, look, the smallest county, it has already 8,000 people, and I'm adding this almost the same amount. So this is like 100%. So here the impact is going to be much, much bigger. Okay, it's much bigger here than here. So this is something that you need to understand. All right, let's read the questions. Select the population statistics that will affect by this population. All right, interquartile range of Florida is going to increase, decrease, stays the same. Mean of Texas, which is the average. Okay, so if I'm taking some people out of the population, all right, and I'll explain that with a problem. The median of Florida, the standard deviation of Texas. All right, so let me show you. Let me add some graphs over here. Okay, so let's get the information that we have here. Let's get I got the Florida information in Texas. Let's get over here. Okay, so here's my Florida population. Here's my Texas. What I want to do right now is to do, so we can understand, I'm going to do what is called a box and whisker plot. I'm going to do a box and whisker plot here and from Texas as well. All right, and we see the difference because we want to see if the mean changes, if the median changes, if the standard deviation changes, right? Those are the three questions that we have. Oh, and interquartile ranges of Florida changes. Okay, so for that, I put the information here on this whiteboard, and now I'm going to do the box and whisker plot. All right, so let me draw it. So now I have the box or whisker plot or the box plot. Okay, this is called either one of them. What happens is the following. Let me get the pen over here. Let me get this. Yeah, blue is fine. So here is the smallest value. My smallest value, 8,349. Here is the lower quartile or my first quartile. Then I have my median. So let's analyze. If this is 27,000, by the way, this is not to scale, obviously. Let's just see that this, because if not, this box will be tiny. All right, so this is 8,000. From here to here is like 18,000. It goes to 27,000, but then you look at this. This is like almost 300,000, which it doesn't make sense, but in order to see the idea. So my median is 107. 107. So this is 300. This is 27. So let's say that this is a 50, 150. So let's say that this is 100. Approximate, right? So right here will be my median, 107. 107 or 56. All right. Median is the middle value of the data. The third quartile, the upper quartile, is 337,362. And the largest value is 2 million. Again, not to scale, because imagine here is almost 2,300,000, which doesn't make sense to these values. I just want to show you the quartiles. Okay, first quartile, this is the second quartile on median, and this is the third quartile. So when they say the range, when they say here about where's the question, interquartile range of Florida, all right, that's what they mean between the first and third quartile. If it's going to change. Again, the second values, the second box, this is the same thing, 27,337, maximum value. Now, the problem says that from the largest, from Texas, went 8,100 people, 8,193, to the smallest county in Florida. So 8,193 plus 83 is going to be 16,500, around there, around 16,500. So that means that from 8,000, I added 8,000 more, and it was to 16,500. But again, approximate, right? Approximate. 16,500 people. Again, this was added to one county. So now the smallest population is not this. We added 8,193. Okay? And now this is the smallest county. But we didn't add any other counties. Now, what happens is the following. So this data change. Let's pretend, and I'm just going to pretend something. So let's pretend that I have, so again, this is 2 million. So let me I want to explain how this is done. So let's say that I have this value. I'm gonna write 7 values right now. Now, these are the 7 values. Some of these values are pretending. Okay, I have the 8,349, which is the smallest county, the 27,000, which is my first quartile, the 50,000, which is pretend, the 107 is my median, the 200,000 is pretend, the 337 is my third quartile, and the 2,617,176 is the largest value, which is my largest county. How do they do these values? How do they find the first quartile, median, and third quartile? So here we go. We count how many data points I have. I have 1, 2, 3, 4, 5, 6, 7. I have 7 values because this is an odd number of values. Then the middle value will be my median, the middle value. So I got 1, 2, 3. So this is going to be my median. Why? Because I have 1, 2, 3 to the right, and I have 1, 2, 3 to the left. Middle value, median, taken already. Now, that's the median, the blue line. What about my first quartile? So, to the left is the first half of the data. To the right is the second half of the data. Okay, so the median is going to divide the whole data in 2 halves. How to get the first quartile? You do the median of my first half. I have 1, 2, 3 values. The middle value is going to be your first quartile. All right, 27,000. Same thing happens with the second half. I have 1, 2, 3 values. The middle value out of those 3 will be my third quartile. And now I have my median, my first quartile, my third quartile. So the first and third quartile, this is what makes the box. First quartile and third quartile. You put a line where the median is. Now this is the interquartile range between the first and third. All right, now we know how to do this box. What about these 2 lines? Those are called the whiskers. So the first line is going to my smallest value, my lowest extreme. And the last value is to the upper or the highest or my maximum value of my data, which is the largest value. In this case, it's 2,617,000. Okay? So that's how you do the box and whisker plot. And this box is going to give you between the first and third quartile. All right. Now let's get to it. It was said that from Texas, from the largest county, it went 8,100 something to the smallest county in Florida. 8,349 plus 8,100 something, 193, gives you approximately 16,500. So the smallest county became 16,500. All right. Now, is that going to affect the order? So now instead of having 8,000, let me cross it out. I have 16,500. Now let's do our new box and whisker plot. Is that going to change any of the other values? No, it's not. So all the first quartile remains the same. So this value is the first quartile. My median is the same, is my middle value. The third, same. My maximum, that's not going to change because this is the order of the data. Okay? All right. So okay. Now, the question here is, interquartile range of Florida. Is that range going to change? Okay, so let's see. Interquartile range goes from first quartile to third quartile. Did these values change? At all. They didn't change because it only changed the first value. It didn't change my first quartile, second, or third quartile. So therefore, my answer here is they stood the same. And let me get a pencil here because I don't have a pencil. Stood the same. They didn't change. Median of Florida. So as we notice, our median didn't change. Why? Because it's the order. So my median didn't change. Therefore, median of Florida didn't change. Stayed the same. Now they're asking for the mean of Texas and the standard deviation of Texas. Now, mean is the average. So let's analyze. Average. If I reduce the number of people in one county, so average, let's say that I have 1, 3, 5, I don't know, 6. All right, I have those values. So I have 4 and 5 is 9, and 6 is 15. So this is 15. All right, divided by 4 pieces. 1, 2, 3, 4. That's going to be my mean, the average. Okay, whatever I get from here. Now, if I reduce the number of one of them, let's say that I still have the 1, 3, 5, but instead of the 6, let's say that decrease, like here, they subtracted 8,000 people. It doesn't matter how many people subtracted. It's just a matter of it went down. Okay, now how many people I have? 4, and 5 is 9, 13, divided by 4. So if I divide this by 4, let's get the calculator. 15 divided by 4, I get 3.75. Alright, so this is the mean, this is the average of these 4 numbers. Alright, I'm making a small example just to prove this. Now, if one of those values decreased, it went down like this, I subtracted this, so this number obviously went down. Then it's going to be 13 divided by 4, and 13 divided by 4 is 3.25. So look at this, my average went down. Therefore, the mean of Texas, because I subtracted, it doesn't matter how much it went down, it decreased, right? It decreased a little bit, but it went down. Now, standard deviation. Now, just to do the standard deviation, I need to understand what the standard deviation. So let me explain. Let me get the formula. So here we have the formula for the standard deviation. Okay, I'm not going to explain the whole thing, but I just want to make you understand what's happening. So here in the standard deviation, I have x bar. This x bar is the mean, all right? The average. Average, and those 3 dots means, it's going to happen for every single value, the data value. X1 is every single value, right? So what happens in standard deviation, this symbol means the standard deviation in this case. It's the square root of the mean or the average minus every single value, and then your answer to the second power. Then you do that with the second value and so on and so forth. Let me take those values that I did on the previous one. I believe here we go, pencil. All right. So if I'm going to look for the standard deviation, I think I have 1, 3, 4, and 6, I guess. You know what, let's do something easy. 1, 2, 3, 4, and 5. This is 3, 6, 10, 15. All right. So these are my 5 values. If I want to find the average, the mean, which is my x bar, then I'm going to add those values. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. So it's 15 divided by number of values, which is 1, 2, 3, 4, 5 values. So my mean, that x bar means mean, is 3 in this case. I'm going to find the standard deviation. How do I find the standard deviation? All right, square root of my mean, which is 3, minus every single value, minus 1, second power, plus 3 minus the second value, 2 to the second power, plus the next value. So I got to do the same thing with every single value, to the second power, plus the fourth value, 3 minus 4 to the second power. And I have the last one, plus 3 minus 5 to the second value, divided by the number of terms that I have, or the 1, 2, 3, 4, 5 values. That's how I find my standard deviation. All right, I'm not going to do the whole math. Okay, so the question is, what happened when the standard deviation of Texas? Remember, I subtracted to one of the values from Texas. So that's what we need to understand. If I subtracted from one of the values of Texas, let's pretend about that 5. So all the way up to here, it's the same values for the new standard deviation. But if this 5 turn into a 2, right? Then 3 minus 2 is going to be 1 to the second power is going to be 1, right? But 3 minus 5 is negative 2, square is 4. So before I had a 4 here. After I subtracted those 8,000 people, my number is going to go down. So if this value here goes down, when I divide by 5, it still is going to be down. And if I do the square root of that, it still is going to be lower. So as soon as I lower down one of the values, my standard deviation will go down. It will decrease. Okay? So therefore, standard deviation will decrease because one of the values went down. And this is the way you find the standard deviation. Those three dots means whatever amount of data you have, you got to do the same process for every single one of them. If you have 100 values, then it's going to be 100 of this. Mean minus the first one, mean minus the second one, mean minus the third one, every single one to the second power. So you're not going to get a negative value out of any of this. Once you raise it to the second power, all of them are going to be positive, positive, or here in this case is 0, positive, positive. 3 minus 4 is negative 1, but to the second power is 1. So you're going to add all those values. But as soon as one of the values, the data values, one of these went down, therefore the standard deviation goes down as well. Okay, I hope it's that clear. This problem was a little bit difficult because it was a lot of topics, mean, median. We didn't talk about mode. That was the only thing that we missed right there. Interquartile ranges, box and Wix's plot, but this is the way you analyze data. Okay, specifically population. This is very popular. Okay, guys, I'm going to stop right here, and then we go fresh for the second video. This question was really, really long. Again, please subscribe to the channel, thumbs up to the video, and hit the notification bell so you can get the future videos about the EOC. Okay, Algebra 1 EOC review. All right, guys, I'll see you next one.